Hello students. Uh, Today I am going to discuss another problem on fluid mechanics, which is basically based on terminal velocity and a viscous drag force. This question was asked in JEE Mains 2025. It's a recent question. So now the question says a small ball of mass m and density rho is dipped in a viscous liquid having density rho naught. After some time, ball falls with a constant velocity. Calculate viscous force acting on the ball. Okay, so let me draw the situation. Ball falls here. Okay, here is a liquid of density rho naught. Rho naught is the density of the liquid area is given. Okay, and a ball okay, now this is the ball here that falls in the liquid of density rho naught, and this ball is having the density rho. Okay, density of the ball is equal to rho, and mass of the ball is equal to m. Okay, so this is given, and this is the density of the liquid. Rho naught is the density of the liquid. এতিয়া যেতিয়া এই বলটো ইয়াৰ মাজেৰে যাব through this viscous liquid, okay, তেতিয়া কি হ'ব? It will have a viscous drag force. Okay, viscous drag force that will oppose the motion of this ball. Okay, viscous drag force কি কৰিব? বলটোৰ মোচনক অপোজ কৰিব। কিন্তু কি কৈছে? After some time, that সোমাই যোৱাৰ পিছত, okay, after falling through this viscous liquid, the ball attains a constant velocity. Now here is the this constant velocity means what? Uniform velocity. Constant velocity মানে হল তোমালোকৰ uniform velocity, and it will happen only when there is a net force of 0 on the ball. Okay, net force যেতিয়া 0 হ'ব তেতিয়াহে constant velocity যাব পাৰিব. Okay, so আমি এটা force diagram draw কৰি চাম. Draw কৰি চালে in the downward direction there will be weight of the ball. Okay, that will be mv into g, mass of the ball into g. Upward কি থাকিব? Upward থাকিব buoyancy force, right? Buoyancy force, which is equal to mass of the liquid displaced into g. At the same time, it will have a viscous drag force which will oppose the motion of the ball. Okay, it will opposite থাকিব, বলটোৰ মোচন হৈছে তল ফালে, আৰু ইয়াৰ viscous drag force to কোন ফালে থাকিব? ওপৰ ফালে থাকিব. Let the viscous drag force be f. Okay, let f be the viscous drag force which we need to calculate. Viscous drag force. Okay, so now for the equilibrium, of this ball, total upward force must be equal to total downward force. this viscous drag force plus force of buoyancy must be equal to weight of the ball, right? Weight of the ball. Okay, that is, this is your viscous force plus buoyant force, this is equal to weight of the ball. Now we need to find out this one. Okay, viscous drag force. Okay, so for this, you see, F equal to, what will be the FB? It will be WB minus F buoyant. Now what is our F buoyant? F buoyant is equal to mass of the liquid displaced into G. So mass of the liquid displaced will be density of the liquid, that is rho naught. Then volume of the body submerged is equal to volume of the liquid displaced. Volume of the liquid displaced, that will give you the mass of the liquid displaced. Okay, this will give you the mass of the liquid displaced into G. Okay, now for WB, mass of the ball into G, so it will be rho into VV into G, right? If we put these values here, rho VVG minus rho naught VVG, where VB is the volume of the body. Okay, now if we take the VVG common, rho VVG common, then we will left with 1 minus rho naught by rho, right? So now what is this? Rho VB into G, this is your, you see, this is your weight of the ball. Okay, so it is total, so we can write it as mg, because mass of the ball is given, mg into 1 minus rho naught by rho. So this is our viscous drag force that will be acting on the ball while flowing through this viscous liquid of density rho naught. So the correct option will be, this is option A, B, C and D. So the correct option will be your option A. So I think all of you have understood this problem. Thank you.